There is a pencil somewhere in your house, and it contains no lead. It never did. The word is a 400-year-old mistake that nobody has bothered to correct, based on a misidentification made by miners in northern England who found a strange black rock and assumed they had struck a lead deposit. They had not. What they had found was one of the purest deposits of graphite ever discovered anywhere on Earth, and the discovery would go on to arm the British Navy, trigger smuggling operations, provoke a national security crisis, and eventually put a writing instrument into the hands of nearly every school child on the planet. The pencil looks like the simplest object in the room. It is a stick with a stripe of black through it, but almost nothing about it is obvious. The material inside it was misunderstood for centuries, and the modern version required a chemical process invented under wartime blockade. Let's dig into this properly, because the answer depends on what counts as a pencil. If the question means any handheld implement for making marks, the answer runs back to the beginnings of art itself, with charcoal from fires used on cave walls tens of thousands of years ago. If it means a stick of pigment encased in a protective holder, the actual design, the answer is the 16th century. And if it means the pencil you would recognize today, with graded hardness and a mass-produced wooden body, the answer is the very end of the 18th century, which makes the modern pencil younger than the steam engine. Start with what came before, because people had a real problem to solve. Writing with ink is excellent for permanence, and terrible for convenience. A quill requires ink, an inkwell, cutting and recutting of the nib, blotting, and a surface that will not bleed. It cannot be carried in a pocket, used on a ladder, or handed to a child. For sketching, note-taking, marking timber, or working out a calculation you intend to discard, ink is entirely the wrong tool. The alternatives available before graphite were limited, and each had drawbacks. Charcoal marks readily, and smudges just as readily. Chalk works on dark surfaces and crumbles. The most sophisticated option was the metal point, usually a silver point, a thin rod of silver drawn across paper prepared with a ground of bone ash or similar material, leaving a faint line that oxidized over time into a warm brown. Renaissance artists produced extraordinary work with silver point, and it has two fatal limitations. It requires specially prepared paper, and it cannot be erased. Every line is final. Let's talk about the discovery itself too, because this represents one of the more consequential accidents in the history of materials. Sometime in the middle of the 16th century, a deposit of graphite was found at Borrowdale in Cumberland, in the north of England. Accounts of the discovery vary, and most of the popular versions, a storm uprooting a tree to reveal the seam, shepherds using it to mark sheep, are difficult to verify and maybe later embellishment. What is well established is that the Borrowdale deposit was extraordinary. The graphite was solid, massive, and pure enough to be sawn into sticks and used directly, with no processing beyond cutting. No comparable deposit has been found anywhere else in the world before or since. Everywhere else, graphite occurs as flakes or in impure forms requiring extensive treatment. Borrowdale simply produced usable writing material straight out of the ground. Nobody knew what it was. The substance was black, greasy to the touch, left dark marks, and looked superficially like a lead ore. So it was called black lead or plumbago, from the Latin for lead ore. The misidentification stuck fast, which is why English speakers still refer to the lead of a pencil, and why the German word for pencil translates roughly as lead stick. The material was correctly identified as a form of carbon only in the late 18th century, and it was given the name graphite, from the Greek for writing, shortly afterwards. By then, the wrong name had been embedded in several European languages for 200 years, and was never going to shift. Let's talk about why the government cared too, because this represents a side of pencil history that sounds invented and is not. Graphite has a property that matters enormously outside of writing. It withstands very high temperatures and does not react readily. That makes it excellent for lining molds used to cast cannonballs, producing rounder, smoother shot that flies more accurately. In an era when naval artillery decided national outcomes, a monopoly on the world's best graphite deposit was a strategic asset. The British Crown took control of the Borrowdale mines. Output was restricted, the workings were flooded deliberately between extraction periods to limit supply, and armed guards were posted. Legislation was passed making the theft of graphite a serious criminal offense. Predictably, a substantial smuggling trade developed, with stolen graphite moving through a black market and, according to contemporary accounts, being traded in the back rooms of local pubs. The pencil, in other words, spent part of its early life as contraband. The earliest pencils were simply sticks of Borrowdale graphite wrapped in string or sheepskin to keep the user's hands clean, since the material transfers readily to skin. Encasing the graphite in wood came next, and by the late 16th century, the practice was established in England. The construction method used then is essentially the one used now. A groove cut into a strip of wood, the graphite laid in, and a second strip glued on top with the assembly then shaped. Italian craftsmen developed a variant using hollowed juniper. The trade spread across Europe, and pencil making became established in several German towns, most notably Nuremberg, where the Faber family began manufacturing in the 18th century and built one of the enduring names in the industry. This detail is worth sitting with directly, because the entire European pencil trade depended on a single English mine, and that dependency became a crisis the moment politics interfered. During the wars following the French Revolution, Britain blockaded France, and the supply of Borrowdale graphite to the continent stopped. French manufacturers had no substitute. The available alternatives were impure graphite that produced weak, scratchy, unreliable marks. Let's talk about how that problem was solved too, because this represents the invention of the modern pencil. In the 1790s, Nicolas Jacques Conté, a French officer and inventor, developed a process to make good pencil cores from poor graphite. The method was to grind the graphite to a fine powder, mix it with clay, add water to form a paste, shape that paste into rods, and then fire them in a kiln. The fired rods were hard, consistent, and strong. Crucially, the ratio of clay to graphite controlled the result. More clay produced a harder rod that made a lighter, finer line. More graphite produced a softer rod that made a darker, broader one. For the first time, a manufacturer could produce a deliberate, repeatable range of grades rather than working with whatever the raw material happened to give. Almost every pencil made today still uses this process. A parallel method involving sulfur was developed in Austria around the same period, and it produced inferior results and was eventually displaced. That grading system is where the letters on the side of a pencil come from. The common scheme uses H for hard and B for black, with numbers indicating degree and F for a fine point sitting between them. An HB sits in the middle and is the standard for general writing. Our pencils run out in both directions, with very soft grades producing rich dark tones for shading, and very hard grades producing precise faint lines for technical drafting. A separate numerical system became common in the United States, which is why a pencil is widely referred to there as a number 2, roughly equivalent to HB. The two systems coexist and do not map onto each other perfectly, since grading is comparative within a manufacturer's range rather than defined against an absolute standard, meaning one company's 2B is not necessarily identical to another's. Let's talk about the wood too, because this represents an underrated part of the object. Pencil casing has demanding requirements. The wood must be soft enough to sharpen cleanly without splintering, straight-grained enough to split evenly, stable enough not to warp, and available in enormous quantity. Eastern red cedar was the traditional choice in the United States, and demand was severe enough that supplies became strained, with reports of old cedar fences and barns being bought up and dismantled for the timber. Incense cedar from the western United States eventually became the dominant material and remains widely used, prized for sharpening quality. The distinctive hexagonal shape of most pencils is a practical compromise. It uses material efficiently, provides a comfortable grip, and importantly, stops the pencil rolling off a sloped drawing board. Round pencils are still made, mostly for carpentry, in a flat oval form that resists rolling on a roof. The eraser arrived separately and later, and its own origin involves another misunderstanding of a material. Before rubber, the standard method for removing pencil marks was to rub them with balls of soft bread. Natural rubber from South America was found to lift graphite from paper effectively, and the English word rubber comes directly from that action. Attaching the eraser to the end of the pencil was patented in the United States in the middle of the 19th century, and the patent was later invalidated on the grounds that combining two existing objects was not a true invention. That combination remains contentious in a smaller way today, since many European manufacturers still make pencils without erasers on the end, viewing the attached eraser as an American habit. By the way, if you want to go even deeper into the secret lives of ancient humans, I just launched a full course called The Secret Lives of Ancient Humans. 10 modules, 3+ hours of content covering everything we never talk about on YouTube. What they feared, how they communicated, what hunted them, and much more. Plus an exclusive PDF guide included. Link in the description. See you inside. Let's talk about the variants too, because this represents a set of branches off the main line that solved different problems. The mechanical pencil addresses the most obvious weakness of the wooden version, which is that sharpening is a chore and consumes the object. Designs for propelling pencils appear from the 18th century, with an early patent in Britain in the early 19th century, and refinements followed steadily, including the twist mechanisms and later the click mechanisms familiar today. A significant advance came from Japan in the 20th century with the development of very thin, strong leads beads made using polymer binders rather than clay, which made fine-gauge mechanical pencils practical. The trade-off is real. A mechanical pencil delivers a constant line width with no sharpening, and it gives up the ability to vary line weight by turning the pencil, which is why many artists still prefer wood. Colored pencils took a different route entirely because pigment behaves nothing like graphite. Instead of graphite and clay, the cores are built from pigment held in a binder of wax or oil, and the formulation determines whether the pencil lays down color smoothly, blends well, or resists smudging. That difference in chemistry is why colored pencils generally do not erase cleanly, since wax and oil bind to paper fibers in a way graphite does not. Watercolor pencils add a water-soluble binder, so marks can be dissolved with a brush afterwards. Carpenter's pencils, meanwhile, kept the graphite core and changed everything else, using a flat body and a broad rectangular core that survives marking rough timber and resists rolling on a sloped surface. Let's talk about mass production too, because this represents how the pencil became universal. Through the 19th century, pencil manufacturing industrialized rapidly, particularly in Germany and the United States. Machinery was developed to cut slats, mill grooves, lay cores, glue, shape, and finish pencils at high speed. Costs collapsed. A pencil moved from being a craftsman's or draftsman's tool to being an object cheap enough to hand to every child in a classroom, which is precisely what happened as compulsory schooling expanded. The pencil became the default writing instrument of education across much of the world, a position it has held for well over a century, largely because it requires no ink, no power, no maintenance beyond sharpening, and works upside down in the cold and after being dropped. There is a further point worth noting about why the pencil never got replaced despite enormous competition. Ballpoint pens, fountain pens, felt tips, and every digital device have all taken market share, and pencils are still manufactured in quantities measured in billions per year. The reasons are practical. Pencil marks do not require the instrument to be held at a particular angle. Graphite does not dry out, freeze, or leak at altitude. A pencil works on damp paper, on rough surfaces, on wood and plaster. It can be erased, which matters enormously for drafting, sketching, and any process involving revision. And it is one of the few writing instruments whose remaining life is visible at a glance. Let's talk about why graphite marks it all too, because this represents the physics underneath the whole object, and it is stranger than it looks. Graphite is pure carbon, and thus so is diamond, and the difference between the hardest natural substance known and something that rubs off on paper is entirely a matter of arrangement. In diamond, each carbon atom bonds to 4 neighbors in a rigid 3-dimensional lattice. In graphite, carbon atoms bond to 3 neighbors in flat hexagonal sheets, and those sheets stack loosely on top of each other with only weak forces holding one layer to the next. Sliding a pencil across paper shears those layers apart, and sheets of carbon transfer onto the surface and lodge among the paper fibers. The mark you leave is a smear of stacked carbon sheets, which is why paper texture matters so much and why the same pencil behaves differently on smooth and rough stock. That same layered structure is why graphite works as a dry lubricant, and a single isolated sheet of it is the material known as graphene, which turned out to have remarkable properties and won a Nobel Prize in Physics in 2010. The substance in a pencil and one of the most studied materials in modern physics are the same thing at different thicknesses. One more oddity concerns the color. The default yellow of a standard pencil is not accidental and not universal. The usual explanation traces it to the late 19th century when the finest graphite came from China, and manufacturers painted their premium pencils yellow to signal that association, yellow carrying regal connotations in Chinese tradition. Competitors copied the convention, buyers came to read yellow as a mark of quality, and the color locked in. It remains dominant in the United States, while pencils sold in parts of Europe and elsewhere are commonly dark green, red, or natural unfinished wood. Let's talk about what goes into one too, because this represents a point that has been made famous well outside the stationery trade. In 1958, the economist Leonard Read published a short essay written from the perspective of a pencil, arguing that no single person on Earth knows how to make one. The claim sounds absurd until it is unpacked. The cedar has to be logged, which requires saws, which require steel, which requires ore and coke and furnaces. The logging requires rope and trucks and fuel refined from crude oil pumped somewhere else entirely. The graphite is mined in one country and the clay in another. The lacquer involves castor oil and various resins. The eraser is a compound of vegetable oil, sulfur, and other additives, and the metal band holding it on is brass, made from copper and zinc mined and smelted separately. The essay's point was about the coordination achieved by markets and price signals without any central planner. And whether one accepts that broader argument or not, the underlying factual observation holds up well. A pencil is the product of an enormous number of people, none of whom is making a pencil, and most of whom have no idea their work ends up in one. The scale of modern production is worth stating plainly. Global output runs into the billions of pencils per year, with major manufacturing concentrated in a handful of countries. That volume raises reasonable questions about timber use, and the industry's general answer is that pencil wood comes largely from managed plantations and from parts of trees unsuited to lumber. As with most claims of that shape, the picture varies considerably by manufacturer and region, and treating it as uniformly true across a global industry would be overstating what is known. Let's talk about erasing too, because this represents a property that shaped what the pencil is actually for. Graphite sits on top of paper rather than soaking into it, held mostly by mechanical grip among the fibers, which is exactly why it can be lifted off again. Ink behaves in the opposite way, penetrating and bonding to the fibers, which is why removing it means removing paper. A rubber eraser works by being softer and stickier than the paper. It grabs the loose carbon particles and carries them away, shedding crumbs that take the graphite with them. Vinyl erasers do the same job more aggressively, and a kneaded eraser used by artists works differently again, lifting graphite by being pressed onto the surface rather than rubbed across it, which allows tone to be reduced gradually without damaging the paper. That erasability is the whole reason the pencil dominated certain fields: engineering drawing, architectural drafting, mathematics, musical. Composition and sketching all involve making marks you intend to change. A tool that assumes revision is a different instrument from one that assumes commitment, and for several centuries the pencil was the only practical option for thinking on paper rather than recording on it. The corresponding weakness is permanence. Pencil marks smudge, fade under handling, and are easily altered, which is precisely why legal documents, contracts, and official records have generally required ink, and why exam and ballot procedures in some jurisdictions have made a point of specifying one or the other. Let's zoom out and pull all of these different threads together. Humans have been making marks with carbon for tens of thousands of years, and in that broad sense, the pencil is as old as art. The specific object, though, has a traceable origin. A uniquely pure graphite deposit was found in northern England in the 16th century, misidentified as lead, and used first as raw sticks and then encased in wood. That deposit was valuable enough to be nationalized, guarded, and smuggled. When war cut off supply, Conte worked out how to manufacture cores from powdered graphite and clay, which both freed pencil making from any single mine and introduced controllable hardness grades. Industrial production through the 19th century made pencils cheap enough to be disposable, and the design has barely changed since because there has not been much reason to change it, which leaves an interesting thought worth sitting with. A pencil contains no lead, is named after a Latin word for a small brush, uses a technology developed to beat a naval blockade, and is one of the very few objects on your desk that would still work perfectly if every power grid on Earth went dark tomorrow.